From orbit, the southern pole appears silent. Descending into the atmosphere reveals a surface battered by storms, with temperatures dropping to 90 degrees below zero. This is a landscape defined by stasis. Winds of 200 kilometers per hour sweep across a frozen expanse, where biological life is virtually non-existent. The ice sheet itself reaches a depth of nearly 5 kilometers. To match its height, you would have to stack the Burj Khalifa 5 times, a barrier of solid ice that isolates everything below. This continental glacier acts as an opaque shield. It conceals an entire landmass roughly the size of the United States and Mexico combined, keeping Earth's most isolated frontier hidden from the human eye. Because of this physical barrier, mapping the deep interior of Antarctica is functionally similar to exploring an alien planet. We are only now identifying the features buried at its base. Below the ice lies the Gamburtsev mountain range. It spans 1,200 kilometers, with peaks and valleys comparable in scale to the European Alps. To map the terrain, researchers fly aircraft equipped with ground-penetrating radar. These instruments bounce electromagnetic waves through the ice and off the deep bedrock, revealing the contours of the stone. The resulting data presents a geological puzzle. These peaks are sharp and jagged. By the laws of erosion, millions of years of shifting glaciers should have sanded them down into smooth, rounded hills. Instead, they remain standing, bearing the weight of billions of tons of ice pressing down on them every second. The existence of these mountains proves the continent is not a solid block, but a lid capping complex and massive geological structures. Moving deeper past the bedrock reveals a secondary feature. Crushing pressure lowers the melting point of the ice, creating vast networks of liquid water. The largest of these is Lake Vostok. This underground lake system spans an area comparable to Lake Ontario. It has been sealed off from the atmosphere, trapped in absolute darkness for over 15 million years. Reaching that water requires drilling through solid ice in the coldest climate on the planet. It took decades of logistical planning and endurance to operate the surface camps directly above the lake. In 2012, a Russian research team finally pierced the subglacial lake surface, reaching a depth of 3,769 meters. These extracted ice cores contain tiny pressurized bubbles. Each one is a sample of ancient atmosphere, preserved in the exact chemical state it was in millions of years ago. The water below has remained physically separated from the rest of the planet since long before the first humans appeared. 90 million years ago, this landscape was unrecognizable. Geologic records show the ice sheets receded, replaced by temperate forests and swamps where dinosaurs roamed. This fossilized fern leaf provides physical evidence of that era. Its detailed vein structure confirms that complex plant life thrived where there is now only ice. When global temperatures dropped and the continent froze, those ecosystems vanished. But researchers are now testing the waters of the subglacial lakes to see if any biological life remains. They are searching for extremophiles, organisms capable of metabolizing minerals and surviving extreme pressure without a single photon of sunlight. These conditions mirror the environments found elsewhere in our solar system. Scientists use the Antarctic subglacial lakes as a proxy for astrobiology, preparing to hunt for life beneath the frozen crust of Jupiter's moon, Europa. Finding life thriving in this dark, high-pressure environment shows that biological survival is possible even in the absence of sunlight. Back on the surface, this ancient environment is fracturing. Deep blue fissures and jagged cracks are expanding across the exterior glaciers. The outer edges of the Antarctic ice sheet are destabilizing. Satellite measurements now show melt rates that exceed historical models. This results in the loss of massive volumes of ice, which calve from the shelf and collapse into the Southern Ocean. If these ice sheets collapse, global sea levels will rise, displacing populations in coastal cities worldwide. Furthermore, the influx of fresh liquid shifts ocean salinity. This dilution slows the deep-sea currents that distribute heat across the planet. The stability of our entire global climate system is tied directly to the ice sheets of the South. The data hidden in these depths will determine the trajectory of Earth's rising oceans.